Page 379. So we're going to start in the vocabulary startup. This is chapter 5, lesson 4. We have 2 more lessons, and then we're done with chapter 5. And then we're moving into the new book. So today is all about decimals. So any number that can be written as a fraction is called a rational number. So 1/2, 3/4. Those are all rational numbers. Every rational number can be written as either a terminating decimal. What do you think terminating means? What? Sort of. Close. Terminating decimal. What do you think it means? It stops. Terminating means it stops. It ends. Okay, what do you think a repeating decimal is? It keeps going. It keeps repeating. It's the same thing over and over and over and over again. That's what repeating means. So, they want us to draw lines that match each statement. So a terminating decimal is either the decimal form of a rational number, which is 0.333333, or the decimal form of a rational number, which has a repeating 0.625. Which one do you think would match up to the terminating decimal? The bottom one, because it stops. It stops at 6.625. It ends right there at the 5. If you want, you can put zeros at the end, repeating, but we don't have to. So then the repeating decimal looks like this, 0.33333, and they use those 3 little dots because it means it's going on forever. It never terminates. It never stops. Okay, Jude, down here in the real world link, is buying fruit snacks for party favors. He asked the cashier for 1/2 pound of fruit snacks. So number 1, explain half as a fraction. What's it look like as a fraction? 1/2. So that's the fraction form. Now they want us to write that as a decimal. So how would that look as a decimal? So just 5/10, 0.5, 0.5. Okay, if Jude wanted to buy 1/3 of a pound, what would the decimal look like there? So hold on, let's make it a fraction first. So what's it look like as a fraction? 1/3. Now if we turn this into a decimal, okay, what this means is you're doing 1 divided by 3. So now that you have calculators, go ahead and do that. 1 divided by 3. So it should be 0.33333, repeating on and on and on and on forever. That's why we use those 3 little dots at the end. Okay, when you have all that, go ahead and go on to the next page. Alright, so on the next page, at the very top, that is what they call rational numbers. So rational numbers are any number that can be numbers, which you'll talk about later, probably 7th and 8th grade, are talking about numbers that can't be written as a fraction, like pi, 3.14159, so on and so on forever. It never repeats and never stops, terminates. Like these right here, so this 0.8, that stops. It terminates. It stops at 0.8. -1/2, that's a fraction. 5 2/3, that's a mixed number. It can be written as a fraction or a decimal. And then this bar right here is called all So subtract, we get 8. Got to bring down another 0. How many times does it go into 80? 6 times. That would be 72. We get 8 again. Drop another 0. How many times does 12 go into 80? 6. You get 72. You get 8 again. Drop another 0. What do you notice? It's repeating, but what number is repeating? 6. So when you write this as your answer, it's going to be written as point with the bar notation. You only put the bar notation over the 6 because 6 is the only number repeating. So whenever you use bar notation, it's only over the numbers that repeat. So like it doesn't when you don't want it to. Okay, so it's because it only has so big of a screen, so it has to show so many numbers. So, but if it's repeating like that, you don't need bar notation. So we have 8/9. Okay, what goes on the inside? 8. What goes on the outside? Drop it, you get 8, drop another 0. 8. What do you notice? It's repeating. Okay, so we got 0.8. So it'd be 0.8 with bar notation over the top of it because 8's the only number repeating. Okay? Now on your calculator, go ahead and practice this. So you do 8 divided. So all you're doing is writing those as decimals, A and C. And pause this. Great. Okay, so you have to put the bar notation over the correct number, the one that's the only one repeating. Okay, so just pay attention to that. Any questions on repeating decimals so far? All right, the next part of this is now they're just going to throw negatives at you. It doesn't change anything. You're still doing the same thing. So all it is that when you have -2/9, that negative just goes straight to your answer. So whenever you see a negative with a fraction, it automatically just goes down to your answer. Then we just worry about the division part. So you get 18, you get 2. Drop another 0. How many times is 9 going to 20? Twice. Get 2 again, drop another 0. What do you notice? It's repeating. Okay, so this would be our decimal. Negative goes in front, and you mix. Nope, guys, we don't need to make an improper fraction. We're just making it a decimal, so where's that 2 go? It goes straight to your answer. It goes in front of the decimal. It's our whole number. divide. Now, they did go ahead and do it as an improper fraction. That's fine, but you don't have to. I think it's one extra step that you don't even need to take. Because, like I said, that 2 instantly goes to your answer. And then now all we're worried about is the 2/3. Six. That'd be 18. We get 2 again. Drop another 0. How many times 3 going to 20? So, what's repeating? Negative 2.6 repeating. Alright, go ahead and try to do D and F. Don't worry about E. Just do D and F. D and F. So if there's a negative F. Letter D, we have negative 1/4. So instantly, since there's a negative, we can put that straight into our answer. Now, since there's not a whole number, I know I can put my decimal down too. So then we just divide. Times 4 going to 10. Get 2 left over, drop a 0. How many times 4 going to 20? 5. So 5 times. So we have nothing left over. So that is what it's called as a terminating decimal. It stops. So all your answer is negative 0.2. You can put a 0 in front. That's fine too. Okay, any questions on that one? So if there's no repeating, okay, you don't use bar notation. It just stops. Okay, letter F, we have negative 2 and 1/6. So now we're worried about the 1/6. So how many times is 6 going to 10? Once. How many times is 6 going to 40? 4. Drop another 0. What's the only one repeating? So the bar notation goes over the 6. So it's negative 2.16 with bar notation. Any questions on that? And you got nothing left over. There's no remainders, nothing. And then this is a repeating decimal with the bar notation because it's the same number going over and over again. You can continue to do this forever and it'll never stop. That's why they call it a real world example. So a lot of this, when you're finding the shooting percentages or batting averages, this is what you're actually doing. Okay, so nearest thousandth, what is his free throw average? So on your calculator, you're going to do 34 because that's how many he made out of the total number he did. Now you should end up with 0.77272727 on and on forever. Okay, but they want us to round to the nearest thousand. 7727. What's in the thousands? 2. This first 2 here is in the thousandths position. Now we're going to round this looking at the number after it. So his free throw percentage is 773 thousandths, 0.773. That's really, really good. I wish I had a shooter like that. Stats don't lie. Okay, that's a pretty good stat. So this applies to real world examples too. So if you play sports, this is how you figure out your stats basically. If you play basketball, you can figure out all types of stuff. It's all about averages. It's all about turning a fraction into a decimal basically. So right now, with a partner by yourself, I want you guys to go to the next. Number 3, number 5, and number 7. So 1, 3, 5, 7. So I'll give you a few minutes. Like I said, you can work with a partner by yourself. So go ahead and get busy. So number 1, we have 7/15. Okay, if we do it the long division way. 7 goes on the inside, 15's on the outside. Put a decimal. How many times 15 go into 70? Over, we gotta drop a 0. How many times does 15 go into 100? 6. That would be 90. We get 10 again. Drop another 0. How many times 15 go into 100? 6. Notation. 0.4 with 6 bar notation. Any questions on that one? Yes. All right. Number 3, we have -8/12. So instant. Okay, so put a decimal, put a 0. How many times 12 go into 80? What? Anybody have a guess? No. It'll be 72. So 0.6 repeating. And now number 5, we do 15 divided by 44. How many times 44 go into 150? Anybody? 12, 13. I'm going to say 3. So that's 132. We got to subtract. Bring down another 0. How many times do you think it goes into 180? 170. Now we get 10 left over. How many times does it go into 100? 2 times. Borrow again. That'd be 2. It's going to be 2 again. Sometimes they go on for a while. You got to keep going with it. 2, 3. Drop it. What's 320 going to be? I think I messed up somewhere. Three, 4, 0, 9, with the 0, 9 repeating. Oh, yeah, it's a teacher edition. Is the batting average. So you would do 34 divided by 99 because that's how many she hit. That's the total amounts. So what's 34 divided by 99? So 0.34 repeat. Now, when we do batting average, though, they want us to round to the nearest thousandth. So if this is repeating, or move up, stay the same. So her batting average is 343, 343 thousandths. Not bad, actually. Pretty good.